Okay, we'll get started in a minute today. But for just let you today, we're gonna do dates, which are an important thing, and regular expressions. I don't know if I'm gonna give you an assignment on this just yet. I haven't committed, but we already have that assignment number 7 out there. We have one more assignment. I'm just trying to think what the best use of that assignment is for number 8. So we have enough points for one more assignment. But today I kind of near the end of the course. Again, like I said, you know the core of the language. I just want to kind of get you to using some of these random libraries that are usually part of the standard library and just things that I think are pretty useful. So we'll get started in a minute, but that's basically what we're going to cover today. We've been dropping a lot of frames lately. Has anybody watched any of the lectures recently? Was it dropping a lot? Not really noticeably? Okay. The tough thing with regular expressions are really important and useful, but there's always, this is probably the best I've seen in a while. The documentation is generally pretty overly technical, but the W3 schools seems pretty decent. The documentation on python.org has never been, again, it's kind of like overly technical. Wait a couple more minutes. We might need to refer back to here, so I'm just going to leave this tab open. Okay. Let's just keep an eye on the rest of the semester. So we've got this week as a normal week. And then Monday we have class, but then don't forget that Wednesday, Thursday, and Friday the school's closed due to Thanksgiving. And then we get back, and then it's like sometime in there we'll do our exam. I'm not sure, either the Wednesday or the Monday. Did I already commit to a date for this class? Can't remember if I did. Some of the classes already announced the date for the final exam, but I guess I haven't. Okay. And just keeping an eye on your assignments, like I mentioned. We have assignment number 7 out there. That's due on Wednesday. I think a lot of people have finished it, but I'll give you some time at the end of class today to keep on working on that. I'm not going to give you any new examples of like working on the web. Just refer to the lecture. And then we have enough points left over for one more assignment, so we'll have an assignment number 8 at some point. Maybe I'll give that to you either Wednesday or maybe the Monday after. Not sure yet, but it'll be soon. Okay, so any questions on where we're at and where the rest of the semester is going to go? How many on, I can't really check because I'm recording. I don't think I graded assignment number 6 yet, have I? No, okay, so I'll make sure to get to that. So that was due last Wednesday. I have some office hours today. Let me see if I can get to that today. And then don't forget that this is due. Okay, so everyone's good. You know where you're at in the semester. You kind of have a general sense of your grade, right? Everyone kind of knows where you're at. Okay. That's the big thing. I don't want there to be any surprises at the end of the semester. So the worst thing is, like, somebody doesn't realize they're failing and they think they have a better grade than they are because they haven't turned in a bunch of assignments, and then they're surprised at the end of the semester. So sounds like everyone's good. Okay. Let's cover dates first. I think dates are probably a little bit simpler. Okay. So there's a module. Remember what a module is. Modules are basically reusable pieces of software. It's a collection of classes and functions and other things, and you import it. And we've got a module that handles dates and times, because that's actually a very common thing. Is when you're programming in the real world, you need to know dates and times. The current time, date difference, like, you know, how many days have passed between date A and date B. Comparisons of dates and times to know if a date is in the past. Those sorts of things. Okay, so there's a special module for that. Let's go ahead and open up a new REPL, and we'll start working with that a little bit. Okay, so the very first thing, if we want to work with dates and times, we have to import DateTime. Now the tough thing with this module and a lot of modules is that it's kind of an awkward syntax. Because anytime we want to do anything, because we imported the DateTime module, but then there's a DateTime object. And so now anytime we want to do something with it, we have to type in DateTime.DateTime dot whatever, which is a little bit awkward. So what we'll do sometimes is we'll kind of have an alternative syntax. We'll say from DateTime import DateTime. And so what that's saying is go inside the DateTime module and import DateTime. It makes it so that we don't have to put it twice. I realize that's probably confusing, but it makes it so life is a little bit easier. Now I can refer to it as DateTime dot, you know, time or whatever, or now, or whatever I want to get. Okay, so we do from DateTime import DateTime, makes it a little bit more convenient. Now if I just want to get the current date time, it's very simple. I just do now. So let's do print DateTime dot now. Now some of these things get like a little bit tricky because you have to worry about time zones and UTC and all that. I don't really want to get into that in this class, but always keep that in mind, is that if you're writing a simple system, it's not that big of a deal. You can just deal with local time. If like I'm just writing a script to parse some logs at a server at IRSC, well, IRSC has exactly one time zone. But if you're working with very complex systems where time zones become kind of important. Let's say, for example, a billing system that cuts off at midnight. That becomes an issue because like somebody goes to pay their bill in California, and let's say, for example, you have it set to Eastern time. These are the sorts of things you have to worry about. In general, the rule of thumb tends to be store everything in what's called UTC, which is basically like kind of like the, I don't know a simple way to describe it. You know how like we have all the time zones? That's like the first time zone. That's like the main time zone that determines when each day passes. It's called UTC. And store everything in UTC, and then when you go to interact with the user, localize it to their time zone. Okay, so that's the general rule. But anyway, I don't want to get in time zones because it gets very complicated very quickly. But as you can see here, it gave us back our date and time. Now, for anybody who's interacted with databases before, this should look somewhat familiar. There's a name for this particular format. It's called like ISO or something, DateTime, for, you know, some ISO standard. But the basic idea is that you go from the most broad to the most specific. So year, month, day, hour, minute, second, millisecond. Okay? Actually, that might be microsecond, right?
Something like that.
Yeah. That looks like too many numbers to be a millisecond. Because milli means 1,000, so it'd have to be between 0 and 999. But, okay, so we have that. So that gets the current date and time. So if we want to pick off individual things from that, we can. So let's say, for example, we said that x is equal to datetime.now. And we're calling a function on a module. Okay, so we've got our datetime module and we're calling a function on it. And so now that's stored in x. So if I printed the type of x, we can see it should be type datetime or something similar. Yeah. And so if we wanted to get the individual year, we could do that. (2019). And this could be convenient because, say, for example, you wanted to do some date math. You could say, okay, the current year minus the year 2000 tells us how many years since the year 2000. Let's try to run it again here. There we go. Okay. So you can do some simple arithmetic with that. Now, we don't always want the current date time. Sometimes we want to specify a date time, and it follows the same basic pattern. And I think the constructor actually takes it to where we can go down all the way down to the millisecond. At least the second. We'll try that in a minute. But let's try this first. So if we want to specify a specific date, we can say that x is equal to, we'll just keep on using x. Date time. Call it in the constructor. Trying to think of an important date, like in Back to the Future or something like that. We'll just say from 10, 9, or just any date. Okay, and we can see how it zeroed out the hour, minute, and second, but it gave us back a date object for that particular date. Now I'm pretty sure we can do date math directly on the datetime object, so let's see if we can do an example of that. So say, for example, before we did the difference between years, but let's say, for example, I wanted to know exactly let's try this real quick. So if we did datetime dot now minus x, let's see if that gives us a date time of the difference. There might be a special. Let's see if it. Okay, perfect. So that's kind of cool. See how that gave us an object of the difference, and I'm just curious the type. I have a feeling it's probably not a datetime object. It's probably something else, like datetime.difference or something. Yeah, time delta. So pretty useful module. Can do all kinds of cool things with it. And a lot of times if you're dealing with a database or interacting with the database, you can insert stuff as a string, but a lot of times it's more convenient to work with these objects because we can do like date time differences and stuff like that. Now, one of the things that you can do here is that if you have a date time and you want to format it to a specific format, you can do that. And they have these formatting codes. So this is str for string, f for format, so string format time. So that's just the last date that we used here, this x. Let's keep on using this. So we would do x.strf time, and then a time format. So let's say we wanted to say October 9th, 2000. We would look up the table here. So we can have the short version of the full version. Let's get the full version. So we do a %B. So that should give us the full word October. Let's go ahead and test that. Oops, and then we got to print it. Let's do this. We'll store it in a variable called stime for string formatted time. And then let's print stime. So that gave us October, perfect. And then we can either have the short day or the full day. By the way, we've got some other cool things here too, like the day of the week and so forth, but day of month. Let's do it padded. Or no, let's do the non-padded version. So I think it's like an M. No, it's not M. Weekday short version. Weekdays number. They don't list. There's a non-padded version here somewhere. We'll just use the padded version. So we'll do %d. And then we'll do the full year, which is capital Y. Now what's interesting is we're not stuck to just these. We can, for example, if you wanted to put commas in there and stuff like that, we can do that as well. So if we wanted year, day, comma, so like October 9th, comma, and then the year, we can do that. So we tend to do this when we want to format it to where a user can see it. That's the general, time we do this. Most of the time, if we're just working within a program, we tend to store things in this right here, this ISO data format. Okay, so that's the basic of dates and times. That's a pretty useful module. Now there is one other thing that I want to talk about. Is there's something called Unix Epoch Time. And this is basically the number of seconds since January 1st, 1970. So you could probably just calculators. Yeah, right here. Okay. So this is the number of seconds since January 1st, 1970. Does anybody have an idea why this might be useful? So what type of number is this? Or what I guess I kind of gave the answer. This is fully stored as a number, correct? Like an int, versus some of these other things are stored as like a DateTime module. If I've got a date that I want to create in Python, but then have it read in another language like C, and then within C I need to do some date processing and stuff like that, what do you think the easiest way to do that is? As a DateTime object and try to serialize and do all kinds of other stuff with that? Probably the easiest way is just to send them an integer. Send them this number. Now the reason this becomes useful is because languages that don't have very sophisticated DateTime modules like Python, it's very, very simple to do math. So if I've got a date, again, like October 9th, 2000, I convert that into epoch time. I convert today's date and time to epoch, and then what I can do is I can find the number of very easily just by subtracting one number from another. I can find the difference between the two. So the reason that this is important is because it becomes it's just very simple to work with, especially in languages where, like Python has a pretty robust DateTime module. Like we saw that we could, if we wanted to do date math, it was very simple. We could just subtract two DateTime objects, but not all languages have that. So this can be kind of useful to work with. Now because I had to look it up because I don't use it in Python that often, but you can actually call a method called timestamp on that. So we can go back here and we still have our date here. So what we can do is we can just call print x.time stamp. That'll also probably take it one step further and give us the number of microseconds. Or maybe not. No, that just goes down to the number of seconds. And just to confirm here, yeah, so that's going to be, so yeah, because we're not talking about now, we're talking about 2000. That's why those are off a little bit. This is actually a super popular way, just kind of a little quick history, not related to programming. This is a very, very, very popular way to store dates and times in various places, in log files and other things, in systems. Does anybody remember the year 2000 bug? So what was the problem in computer systems that we had a bug in the first place? Does anybody remember why banks were freaking out? So basically it was people writing software in the 60s and 70s, you know, they thought, oh, technology's moving so fast, people are going to use this software for a couple of years and then they're going to trash it. And then what happened? People didn't just use it for a couple of years, they used it for 40 years. And then back then, we had such small amounts of memory, computer memory and storage, that it just became the norm to store dates as the 2-digit year. So like 1997 would just be stored as 97. Well, obviously, if you're trying to do date math on that, what happens when you roll over to the year 2000? Instead of like 97 minus 94, you end up with like 97 minus 0. And then it causes all kinds of problems. So, but they fixed that. They went back and rewrote a lot of software and got a lot of those problems fixed. There's actually another, we're into that situation again. What's the highest number I can store in 32 bits? Okay, so let me take a step back. How many people, maybe a little bit older here, not necessarily my age, but who have been gaming for a few years, and you remember that at one point we had a 4 gig limit on RAM in computers? Does anybody remember that? That was kind of a while ago. How many people remember that? Does anybody know why what that specific number 4 gigs represented? 32 bits. 4 gigs is 4 billion. So essentially the limit that we ran into was that on a 32-bit system, the highest we can count up to is approximately 4 billion. 4 billion and some extra numbers, because it's all base 2. So what is going to happen on 32-bit systems once we reach 4 billion on this number? It's going to roll over. We're going to have the same problem again. So there's a name for it. I can't remember. Yeah, okay. So it's going to overflow in the year 2038. It's called the year 2038 problem. It's basically the same problem. They've created the same problem again. 2038 is a little bit of ways away, and to be honest, we have so many 64-bit systems out there that it's not going to be as bad. But you'd be surprised. There's a lot of systems out there that are still 32-bit. Not stuff that we see on an everyday basis, but think about like chips that are maybe inside of your car, or stuff embedded in like industrial systems, you know, those sorts of things. Those very well may have 32-bit computers or 32-bit processors in there. So just something to keep in mind about 20 years from now, that this will probably be in the news. That being said, I still use Unix Epoch Time, you know, whenever needed. It's not something to be afraid of. I think it's still pretty useful, because especially if you need to send a date to another language, and you need minimal parsing, and you want to just be able to do date differences, that becomes pretty convenient. The other portable way is this right here. This is an actual standard, an ISO standard, but sometimes it's just easier to deal with a number than just to try to parse this out and find a library. Just send me an integer. I'm good with that. That's all I care about, is dealing with integers. Okay, so that's basic dates. And you can do local time zones. You can do all kinds of other interesting stuff. But I just wanted to introduce you to that module. So the one that one's fairly simple. Let's get in one that's a little bit more complicated. Is regular expressions. How many people have at least heard of regular expressions before? A few people. How many people have worked with them before? Okay. So they kind of have a. By the way, this is in. I should have mentioned this before. This is inside of your resources under W3 Schools Python, or you could just Google W3 Schools Python regex. A regular expression is basically, I've got a bunch of text and I want to match some patterns. The first programming language I ever learned was a language called Perl. It was actually probably a pretty terrible language to learn. Has anybody heard of that language before? It's a pretty terrible first language to learn because it kind of gives you a lot of bad habits. But the reason I learned it is because at the time, if I wanted to write web applications, we were going through that period of like static web pages to where people started to do basic things online on web pages, like, you know, database interaction and forms and stuff like that. And one of the best languages for that was a language called Perl. The reason for that is this language called Perl had something called regular expressions built into the language. And because it made it so easy to process text, I could do things like very sophisticated user input validation and deal with like basic parsing of things like HTML when necessary. And it made it very, very convenient to work with. And so regular expressions kind of became popular with Perl. They predate Perl, but that's where a lot of people got exposure with them. And other things like sed and awk and stuff like that. And grep even has regular expressions, but it's basic text processing. Now these days, the place you tend to use regular expressions the most is, especially if you're a system administrator, is if you have a bunch of log files and you need to parse those out somehow. So let's say, for example, yeah. Oh, you're just stretching.
Well, I was wondering. I recognize them. I think they're built into Java.
Correct. Java has them as well. Yeah. Now it's interesting because the difference between with Python and Java versus Perl. Perl, they actually built them into the language. With Python and Java, you import them as modules. Perl was cool because they actually have special characters, but people felt that it was better, you know, not being a part of the language. And I guess I agree that it's better as like a separate module. But you're exactly right. Yeah, Java has them as well. Let's see. Okay, perfect. So this is an example of an Apache log. And let's say, for example, Apache is just a web server. Now, let's say, for example, I wanted to, there's a very specific error I'm looking for. This is perfect right here. And so I'm under some sort of attack and, you know, I'm in a hurry and I'm trying to find exactly what IP addresses are sending malform host headers. Then I'd go to my Apache logs and I need to be able to get this information somehow. And then not only do I want this, but I want a list of all the IP addresses. They just shortened it, but this would be an IP address. It wouldn't be 1.2.3. It would be like 192.168.30.8 or whatever. So just parsing this out normally would be actually a little bit of work, especially because these IP addresses are going to be variable length. You could think, oh, okay, well, I'll just count the number of characters. That's not always the case because these, you know, IP addresses are going to be variable length. And I have to find this in here, and it just becomes somewhat of a problem. That's where regular expressions really shine, is because I can say, okay, find this particular substring inside of this larger string. And then we can get even more sophisticated pattern matching. And actually, maybe we'll do that in a second here with this particular example. But going back, so that's what they're for, is they're for finding text in larger pieces of text. Now, to use it, we import it. It's a separate module. And we're going to use a few. The basics that we're going to use is one called FindAll. And this gives us a list of all matches. So let's start off with that one. So let's go to FindAll. And we could copy and paste, but I think it, oops, pulled over the wrong REPL. I think it might be useful to just kind of type this in. Okay, so just like with the DateTime, we import it. Now this one's the DateTime.DateTime thing, that's specific to DateTime, just how they organize their module. With regular expressions, when we import RE, it's just everything's available. Like if we wanted to do a FindAll, we could just do re.FindAll. Okay. So here we have a string. Let's not use str. Let's just use s. And so we'll write s equals the rain in Spain. So that's our starting string that we're working with. You could think of this as like our log file. Now, directly on the RE module is a function called FindAll. And what we do is we pass in what we want to find and then basically our reference string. So what we can say is that the result is going to be re.FindAll, and I think they looked for the string AI, and we want to find it inside of S. And then we can print result. So that may or may not be useful to you because, for example, if I wanted to know the number of times something matched, what could I do with this? How could I find the number of times the letters AI are in this string? Well, what data type is this? With the square brackets, what is that? A list. And so what can we call on a list to tell its length? Exactly. So what we can do is result. I'm sorry. So it's we do len results, and then it tells me, okay, I found this substring 2 times in there. So that's one use of it. And that can be useful. The other thing that we can do is, and this is where the important part starts. This is just finding a substring. This is not that interesting. But what we can do, is it not listed here? There we go. Okay. We have this idea of meta characters. Actually, sequence characters. That's what I'm concerned with right now. And what we do is we do a backslash, and then let's say, for example, I want to find all white space characters. So tabs, spaces, and if they hit the enter key, like returns, new lines, all that sort of stuff. Basically anything we can't see. So what we could do is, actually let's do a better one here. Let's do D for digits, and let's find how many digits are in another string. So let's say there's another string here. And let's say I have 4 classes that'd be 2020. And I want to know the number of digits that are in that string. So what I could do is re.FindAll, and \D is for digits. Now we run into a problem. Has anybody run into the backslash problem before in strings in either the Linux class or another? So what happens is that these backslashes can cause problems. So anytime we want a string that's a regular expression, what we have to do is we have to put an R in front of it. So anytime we're using like these special characters, we just want to put an R in front of it, and that makes it a regular expression string. Otherwise, it gets interpreted weird. We'll experiment a little bit more with it, but so then we have the result, and then we can print result. And it gave us back that we had the number 4, 2020. Now, sometimes these strings work without the R, sometimes they don't. Just out of curiosity, I'm going to see if it works without it. Sometimes you can forget and it'll still work. Yeah, in this case it worked, but in general, it's just it's a good idea just to put the R in front because you don't end up with these backslash issues that can cause all kinds of problems. So this kind of works, but what if I wanted to say this is one number and this is one number? Because if I were to do len result, what would it return? 5, because I have 5 digits. But let's look through this a little bit more. Let's look at these special meta characters. So one or more occurrences in a row, essentially. So if I wanted to use this plus, let's see how I could use that. I would do \d for digits, and then we have these modifiers afterwards. And what the plus does is it basically says group these together. So here it would say, okay, it found one digit, that's fine. The rule is one or more, and then it found a non-digit. So great. But here, it finds a digit, and then another digit, and it keeps on going, and it's able to group these together and understand that this is one number. So now if we did this, it would print 4 and then 2020. See the difference? So these modifiers are very, very, very powerful. Now you don't have to just use them by themselves. Like you can use this, in another way. Let's say, for example, I wanted have 4, or you get the idea right here, right? Okay, so that would give us back 4, but here we're just concerned with the digits. Okay, so let's keep on going here with another example with Give me 1 second. Does it work on this? No, it doesn't. Okay. So, in the previous example, if I had a let's say for example I'm writing some sort of text crawler, and this is like for Twitter, and I'm going through tweets. And I'm looking for various ways that somebody could write how many classes they have for spring 2020. And like a bunch of people on Twitter wrote, I have 4 classes, I have 7 classes, and so on. But I know it fit this basic pattern of saying I have this number of classes for that semester. What if I just wanted the 4? Because right now, this is returning too much. This is returning all digits. And if I write this, it captures both. But what if I'm only concerned with the 4? Okay, so what we can do here is use another one of these functions. I'm pretty sure it's search will do this. I guess we'll just try. Okay, so we'll say, we'll keep that same string, and then we'll say this time is that result is equal to re.search. And then what we do is we put it in parentheses. Bless you. And it just captures the stuff in the parentheses. Because this is only going to match once, because it's going to look for have, space, and then a number. And all we're concerned about is the number. oops, and then we have to pass in the string. So re.search and then the string s. Now it returned a match object, and I think there's in here, it's called group or something like that. Groups. Yeah, and then see how it returned back the number 4, and so we would grab. It returned it as a list, actually a tuple, and we would just grab the first occurrence of that, and then that gives us back just the number. So let's take a step back. So this FindAll, the way FindAll works is that it just gives us back strings. Now search is interesting because what search can do is it returns something called a match object. If I were to do print type of result, I'm pretty sure it'll return, it's called a match object. Yeah, a match object. Now match is kind of interesting because it gives you a bunch of extra information. Here we go, match object. It gives you the span of where it starts and ends. So you might care about not only the string, but where it occurs. Does that make sense? Like remember this example, it just gives us the A's and the I's. But what if I wanted to know where in the string those A's, I's occur? Does that make sense? So that match object can give us that. We can get the actual string. And then we can get the groups like we did here. I wonder if singular works. Okay, I wonder if we can just call group and still get the information. No, okay, so when we do groups plural, it's going to give us back in the parentheses. And then we want the 0th version of that. So this match object's a little bit more powerful because then what you can do is you can take unknown things and then you can start to get information from them. Okay, so knowing all that, let's. So anybody need a second to copy this down a little bit more? So let's do one more example. I'll try to keep it short, and that way you can have the rest of the class to work on your other assignment. Again, no new assignment this week. Let's open up another REPL here. And let's do a real-world example. So let's, actually, let's open this. So go to Files, and let's add file, and we'll call it log.txt. Let's pretend this is some sort of log file. And let's just write this. We'll say in log.txt, it's going to be like, it'll either be error or success. So it'll be, let's say the first line was success. And then it's going to be in school. We'll just say it's an IP address, and it's always going to be an IP address. And then some sort of command like put, like we're putting a file or something like that. And then let's say we've got a couple more successes. And they're from different IP addresses. This is just a made-up log file, by the way. It's just to make our life simplified. And then we also have that there can be an error. And then it's going to be IP address. And then maybe a simple error condition or code or something like that. We'll keep it simple. We'll just have this We'll say that they tried to post and there was some sort of error. And then let's kind of mix these up a little bit here, just so we've got them a little bit out of order. So we have 2 errors, and the rest are success. Okay, so that's our log.txt. Very simple. Just either success or error, IP address, and then some sort of HTTP command. So now let's go back over to our Python file. And remember, we did running through individual lines in a text file, right? So just as a reminder, to do that, what we do is we say with, and there's a function called open, and then we pass in the file name. So here it's going to be log.txt, and then as, and this gives us back like a file reader. And so this, if we can use this basically one line at a time. So I can say that line is equal to f, and it's going to give us back one single line. And just to see that, let's go ahead and print line. Should it give me back a oh, sorry. It's now I have to iterate over it. So for line in f, print line. Sorry about that. So what that does is this creates something called a generator, and then I can loop over each individual line one at a time. Now what's the problem here? What do we have an extra little at the end? We have an invisible new line character. So we want to strip that out. So one of the first things I almost always do when I'm doing this type of text processing, I say that line is going to equal line dot rstrip, and that strips off any extra white space at the end. And then now if I were to print line, it wouldn't have the extra stuff at the end. And let's say, for example, I just want to see the IP addresses that have had an error. So we know we're going to use the RE. So I'm going to import RE. And what I want to do is re dot FindAll. Actually, I might be simpler to use search, because I think search will return null. Let's try search. Side by side. And we're going to look for the string error. Full word error inside of line. So what do you notice about some of the lines? Some returned the RE match object, but what do you notice about the lines that don't have the word error in it? What do they have instead? None. None's a special keyword in Python. It basically is like null or nothing. And so what we can actually do is if we're just checking for errors, we can say if result. So if it equals none, then we know everything was okay. So we want to just look for the stuff where it's not equal to none. And then that means that we have a match object. So now we could go through and do another call, do another re.search, or it could be a little bit clever about this, is that our regular expressions can be a little bit expensive computationally. So what we can do is we can search for the error and the IP address in this original. Because it's going to be of a certain format, what we can do is we can say search for error, and then there's going to be some sort of IP address. Now the format for the IP address is going to be some numbers, dot some numbers, some dot some numbers, dot some numbers. So what we can do is we can say some numbers dot some numbers. Let me expand this a little bit. Dot some numbers dot some numbers, and then a space. Remember that was the format of our log file. Is numbers dot some numbers dot some, and then a space afterwards. And so that's what we're looking for here: error, and then an IP address. Now, because we're using these backslashes, remember that we have to put the R at the beginning to let us know that we're working with a regular expression. And there's one more problem. When we're dealing with these regular expressions, there's a lot of special characters. If we go back here, the dot is actually a special character. Dot actually means match anything. So any character, the dot. And so we have to be careful about that. So what we have to do here is we have to put a backslash in front of the dot. Now, this is why regular expressions get a bad reputation, because to most people, I think that's pretty difficult to read, right? And that's just for finding an IP address. That's a relatively simple thing. But once we have that, it's very powerful, because then what I can do is I can go through my log file, and then remember we could do result.groups. And just because I know my data format, I know it's only going to have one IP address in there. And then from there, I can get all the IP addresses that generated errors inside of my log files. It turns out it's the same IP address both times. Pretty powerful stuff, especially for log files. If anybody in here is going to be a system administrator, you're going to be doing a lot of log file parsing. And regular expressions are extremely, extremely helpful. Okay. So I may do an assignment on regular expressions, but I don't know. We'll figure that out next class. If I do decide to do an assignment on these, I want to make sure that I've explained it thoroughly. I know today I did kind of surface level stuff, just showed you some basics. But okay. So we have about 20 minutes left. We'll use that time to work on the assignment. Any questions about the DateTime module or regular expressions? Okay. Hope this wasn't overly confusing, but at this point in the class, we're getting into kind of advanced stuff. This is like stuff you do in the real world. So, and you notice like sometimes I have to look stuff up. It's because it's like not the basics anymore. Some of this stuff, it's like part of the standard library and stuff you wouldn't use necessarily every day. So, okay, so we'll do that. So for anybody who's already done and turned it in, you don't have to stay for the last 20 minutes. But for anybody else who still needs some help, just stick around for the last 20 minutes. We'll finish out that assignment, okay? And just like usual, if you run into any questions for anybody who's leaving right now, you can go ahead and email me. And I'll post these examples on Blackboard as well.